Hey everybody, welcome to Monday Open Space here on my YouTube channel. As always, this is your chance. Actually, I should say the date. Open Space for Monday, December 7th, 2020. Hey everyone, welcome to the channel. It's been a crazy week. It has been, I cannot believe the amount of news that has come out in the last week. We have been just running hot at Universe today. So many stories. Arecibo, Hayabusa, Chang'e 5, Starship may launch tomorrow, resupply mission to the International Space Station, and many more. So, as always, this is your chance to ask me any questions that you've got about space and astronomy. I have no idea what we're going to be talking about. That's all up to you. Now, I'm trying to get a little bit more organized about these, trying to turn this more and more into, a more of a professional show. So, so by all means, if you have any feedback, any suggestions on how I can make this better, I want to remind everybody a couple of things. One, if you don't have time to join me live here on my YouTube channel, I totally get it. I wouldn't either. So if you want to watch it after, you can. If you prefer to just have it delivered to you as a podcast, you can. I will put all the links in the show notes, but just search for Universe Today podcast everywhere you get your podcasts, and you will get a link to the podcast. And then the other thing I want to do is, I don't know if you've noticed, but there are no ads. There's no ads on any of the live streams that we do. None of the open space, none of the interviews. And partly it's because, there's a lot of ads. We just kind of let YouTube do it, and it was 9 ads in each episode. And so the reason there's no ads is all thanks to the patrons. And so I just want to give a thanks to, shout out a couple of patrons this week. I want to thank Rod James, Ed Lawler, Wes Graff, Ronald McCoy, Henry Felice, Josh Paglio, and the rest of our 850-something patrons. Thank you, everybody, for all of your ongoing support. Because of that, no ads on any of our live streams that I notice anyway. You don't see it on the star parties. You don't see it on any of the live stuff. So, I think that's the stuff. Oh, right. So we had an incredible interview last week with Alex Ignatiev about lunar mining, and I had a lot of great feedback from everybody on that. We've also, the week before we did Wallace Arthur and the biological universe. And so I'm trying to dig deep and try to get some really interesting experts to talk to me in upcoming weeks. Things about, I'm going to try to talk to people about, people have asked me about the Canadian Space Agency. And so I've got Elizabeth Howell coming on Friday. She's going to talk about the Canadarm collaboration and sort of how Canada's space exploration industry works. We have one. It's not just arms. And then also, I'm trying to bring on some experts about some interesting telescope ideas, bio refining. People had some questions about that, so I'm trying to find an expert to talk about that. So I'm trying to get experts who are really pushing the cutting edge of both space exploration and the latest ideas in astronomy research. So the last few weeks of interviews have sort of been on that vein, and I'm going to try to keep that rolling now and forever. So I hope you're enjoying it. Buckle up, there'll be more of it. So the other thing I want to do is just give you a reminder, because like I said, last week was so crazy. We had so much news that I just wanted to just show you it's just some of the stuff that we had this week. And so that way, if you're if there's some questions that you have and you forgot about some of the big stuff that happened, I just want to remind you. Arecibo collapsed. So we've got that. Chang'e 5 made it to the moon, landed on the moon, gathered a sample, flew up to into orbit, docked with a return ship, and the return ship is going to be coming back to Earth shortly. Hayabusa returned its sample back over the weekend and landed nice and safely in Japan. So, in Australia, and they've collected the sample, so that's done. And then lots and lots of other amazing stories. So I'm sort of just showing people here. This is the newsletter that I do every week. I think this was the biggest one that I've ever done. So if you want to get this every week for free, go to universetoday.com/newsletter. And again, this is all thanks to the patrons. All right. Let's go to me. That's giving you all a chance to put some questions in, and let's get started. So Trey Harmon asks, Fraser, I was really intrigued by your Astronomy Cast comments on white dwarfs and the possibility of habitable planets orbiting them. Can you explore this a bit more? No sunburns, etc. Sure. So white dwarf stars are the remnants that are left over when a star like our sun dies. And so the star goes through its main sequence phase for about 12 billion years or so, and then it runs out of fuel. And that's going to happen to the sun in about 5.5 billion years from now. The sun's going to blow up as a red giant, puff out its outer layers, and it's going to shrink down to become this degenerate white dwarf. It's going to end up about half of the mass that it was when it was the sun. And as it loses all this mass, it's going to kick out a lot of the sort of change the orbital dynamics of the planets that are going around it. And it's going to consume Mercury and Venus. It may consume Earth. We're still not entirely sure. But Mars will be fine, and Jupiter and Saturn, they'll all be fine. But their orbits will shift as the mass changes. So here in the solar system, let me just do one more thing here. So you get the white dwarf. The white dwarf then cools down. Now it's still incredibly hot and putting out an enormous amount of heat. It is essentially the core of the star. And so like when the surface of the sun is 6,000 degrees, white dwarfs can be way hotter. And then they slowly, because it's really like you've stripped away all the core of the star and you're left with just the glowing, cooling down core that was, 1,000,000 degrees. So it slowly cools down to the background temperature of the universe, but that's going to take quadrillions of years. None have happened so far. And so it's putting out heat, like a very consistent amount of heat, and there's no more solar flares, and there's no more, there's nothing complicated that's going to happen. And so you can have a planet orbiting around the white dwarf star, and just continue to heat for an incredibly long period of time. The trick is to manage that transition between regular star, heating up, bloating as a red giant, throwing away a lot of its mass, and then turning into this tiny white dwarf remnant. But in theory, as the star is losing mass, then the orbits of things will change, and you could end up in a way that a planet ends up in an orbit that's very tight around a white dwarf. And then you could last beside the white dwarf pretty much forever. So obviously some future very capable solar system engineers will be able to shift the planet Earth away from the sun while it's going through its red giant phase, and then bring it back down close when it goes into its white dwarf phase, and then just park it beside the sun, and then slowly sort of tighten up your orbit as you get closer and closer. So it would require, you could be really lucky and end up with sort of the perfect situation, but I don't think there's like any point in that phase, any point in that process that you're not going to get roasted or frozen. And so you've got to take a hand in being able to manage the transition from main sequence star to red giant to white dwarf. All right, let's move on. Raphael Dominichini, an insect could fly in a zero-G environment like the International Space Station. Yeah, many bugs and animals have been sent to the International Space Station. And they are confused by being in microgravity, but they do figure it out. And so many fruit flies have gone to the International Space Station, other larger insects. Spiders have gone to the International Space Station, and many other creatures, frogs, worms. So when they are in space, they do adapt. And I'm sure for like some of the smallest creatures like flies and stuff, gravity doesn't play that big of a role in the way they get around. They have almost no gravity. It's really the viscosity of the fluid that they're moving through. Those are the forces that they're dealing with. While much larger animals like us and elephants and stuff, they deal with gravity. And so, but yeah, no, for smaller creatures, they can totally handle flying around in zero gravity. Takes some getting used to, but they're able to do it. So Visto Tutti says, with Arecibo gone, who will radar track the next killer asteroid? Are we all gonna die? So, I mean, we're all gonna die, whether it's an asteroid or whatever, except for me, robot body. Gonna watch the end of the universe. So there are a couple of other radar. So okay, let's talk about the radar. Man, my brain is all over the place today. All right. So the Arecibo Observatory, 300-meter observatory, the new Chinese FAST telescope, the 500-meter aperture spherical telescope, is bigger than Arecibo. So it's more sensitive than Arecibo was. And it's brand new. It's in better condition. But the thing that FAST can't do is this idea of radar. And so what happens is, with the Arecibo Observatory, they have that big instrument dish that was in the center of the big instrument panel is up in the center of this, the 900-ton structure that collapsed into the observatory on Tuesday, that contained a radar emitter. And so it would fire out a really powerful radar array. They could shoot it right at whatever target they wanted to be able to do, and then they could receive a bounce signal back from that radar and then collect it. And that allowed them to map the position, the shape of asteroids really great. Now, there are some other instruments out there that can do that. I think Goldstone can do it. Green Bank might be able to do it, but less powerfully than Arecibo could. So right now, without Arecibo, we don't have like a really powerful radar instrument with the same kind of capability. I mean, they used it to, I think they used it to like map or shoot at Venus. They measured the distance to Mercury. They sent a message to aliens. So all kinds of stuff. All right. T. Holmes says, was there anything that they could have done to make Arecibo's collapse less catastrophic, in your opinion, like lower the platform deliberately instead of it falling? We don't know. So when you watch the incredible video of Arecibo collapsing, what made it really kind of amazing was that there was a drone flying right above the instrument package that was scanning like the cables to take a look at it so they could start to figure out whether they could repair what it was going to take. And so the drone was watching as the cable snapped and the whole thing came apart. So we don't really know what could have been done to stabilize it. And, we're talking about this on the Weekly Space Hangout this week, how lucky it was that it collapsed the way that it did, because you can see how incredibly dangerous it was. Anyone getting anywhere close to this site would have been putting themselves in mortal danger. These cables are enormous. The forces involved to hold this thing up would have been just incredible. And so the fact that it at night just went and just, on its own, when nobody was on the facility, nobody had to be in harm's way, and it just collapsed, was great. Was the best possible outcome for an observatory that was doomed. And I think, there's a lot of people that are like super shocked about Arecibo's collapse, and everyone kind of saying there's not going to be a replacement. Like, they're not going to fix it. Because, those of us who've been following Arecibo for decades watched it struggle, watched how funding was pulled, how there was times when they were going to close the observatory down, even though it was working perfectly. So the fact that it's completely destroyed, it couldn't get funding for maintenance before, it's not going to get funding now. So I know people are doing petitions, try and meet and look at it. And by all means, sign that petition. Hopefully someone will realize that a telescope that big with that kind of radar capability is important, but do not hold your breath. So, from this point forward, people are going to have to go to China and use the FAST telescope, or use some of the other big capability telescopes like the upcoming Square Kilometer Array. Ted Krause asks, how does the International Space Station manage the meteors that come towards the Earth? The International Space Station does not in any way manage the meteors that come towards the Earth. It is a target that the meteors sometimes hit. If the wrong meteor's on the wrong trajectory, it will collide with the International Space Station, and depending on the size, can cause minor or catastrophic damage to the station. And in fact, astronauts have done spacewalks out on the station, and they've seen places on the station where space junk of some variety has caused damage, blown out a piece of the station's solar panels. Now, it's not just the meteors just coming from space, and there's a lot of this. Like every year, about 100 tons of mass is added to the Earth because of just debris from the solar system crashing into the Earth. But so you don't have to, they don't have to just worry about meteors. They also have to worry about space debris. And this is our fault, where all of the deorbited spacecraft, other satellites, chunks, astronaut gloves, nuts, bolts, everything is flying around the Earth. And so people have to keep track of this stuff all the time, very carefully. And then when, if it looks like something is going to be on a collision course, it's going to enter a sort of the zone of the International Space Station, then they will fire the engines on the space station to try to help it avoid a future potential collision. Like if an object gets within, I think it's like a kilometer or two of the station, if it's expected to come within a certain zone around the space station, they will move the space station to be absolutely safe. And so you hear every few months they have to perform one of these evasive maneuvers to keep the space station safe. Larry Beckham is asking, who bought Bigelow Aerospace? I had no idea. Did Bigelow Aerospace get bought? That's interesting. I had no idea. Yeah. Does anybody have a... So Dr. Ed Elcott, cryptozoologist, asked, any guesses on what it would cost to construct a new version of Arecibo? I've heard in the $60 to $100 million mark to essentially fix Arecibo in its current state. So that would mean cleaning up the debris, rebuilding the main dish, rehanging the instrument panel, maybe upgrading it a little bit. Probably more than that. I wouldn't be surprised. When you compare other things, like you've got the European Extremely Large Telescope. This is this incredibly large 39-meter telescope that's under construction right now. It's going to be about 1.3 billion euros. So it's going to be expensive. I mean, it's no James Webb. I mean, you could build dozens of Arecibos for the price of a James Webb. But, that's just how it goes. L Shar 666. We know that dark matter is essential for galaxy formation. What about at smaller scales, such as star formation? Do we breathe dark matter too? That's a great question. The big answer is that we don't know. We still don't know what dark matter is. So one possibility is that dark matter could be black holes with about 1,000 times the mass of the sun. That would fulfill the mass composition of dark matter. Another possibility is that dark matter is black holes that are a centimeter across. That would also fulfill. There's like a middle range where it won't work, and there's like a large range where it won't work, but there's some middle ranges where it could be. It could be a particle. It could be that gravity works in ways that we don't understand. Or it could be some combination of all of them. So we still really don't know what dark matter is. But if dark matter is a particle, specifically a slow-moving particle, and this is what most astronomers expect dark matter mostly is, these massive, slow-moving particles. So they don't interact with matter in a regular way, but they do interact with matter through gravity. Then, and if it was evenly spaced across the whole galaxy, the whole size of the galactic halo. And of course, when the Milky Way only measures, say, 200,000 light years across, the galactic halo, the dark matter halo, can be 1 million light years across. It is the actual galaxy. So if you take the mass of that galaxy and you sort of even that out across the volume of the dark matter halo, you actually only end up with about, say, an asteroid's worth of dark matter in the entire solar system. So the whole solar system could be just regular matter, and then somewhere in the solar system there's one asteroid's worth of dark matter, and that would fulfill the density. Now, it could just be in particles, and so there could be throughout the entire solar system, if you take one asteroid's mass, a small asteroid, and just spread it out across the entire sphere of the solar system, that would fulfill it. So you don't really have to sort of worry. Now, are you breathing it? Maybe. I mean, you have neutrinos passing through your body right now, harmlessly. And so obviously, you probably have them passing harmlessly through your body as well, if they are these particles. There's an interesting theory that's been proposed that if dark matter gets into the star, like the sun, then it could be possible to detect just how the radiation is coming off of the star. That could give you some hints that dark matter is there. But it really is just this gigantic unsolved mystery in astronomy right now. Mandanara, thank you for your ad block payment. But remember that these videos are ad free. So if you're running ad block on these videos, you're wasting your time. There's no ads on them. All right. Jonathan Pawelko, are you watching the planetary conjunction tonight and tomorrow? Are you talking about the Jupiter and Saturn conjunction? Those are on the 21st. So we are still a couple of weeks away. Not only will we be watching them, I'm going to try to live stream them so we can just watch it all together. So stay tuned on that. It'll be like a special, super duper virtual star party. Arjone, what other things could an Arecibo engineer do? Are they too specialized to get other jobs? Now, are you talking about like an engineer at Arecibo as opposed to like an astronomer? Sure. I mean, it's like a bridge, same kinds of skills, working on bridges, think about the high tension lines, all those cabling, running high energy instruments. There's all kinds of jobs they can work on. Whoa. All right. Scott D. Whedon. Are there any asteroids in orbit around the sun from interstellar origins, perhaps with unusual orbits? So, obviously you're familiar with Oumuamua and Borisov, which are two interstellar objects that passed through the solar system on hyperbolic orbits, and they're on their way back out. But I guess the question you're asking is there anything that is trapped inside this space station? And the answer is almost certainly. We know, I mean, the fact that there are probably tens of thousands of interstellar objects passing through the solar system right now. Most of them are super far out. I mean, the Oort cloud reaches out to 2 light years away, so they could just be skimming through the Oort cloud, and so most of them are going to be too far away to detect. But there could be some that are coming in, and if they go through some kind of three-body interaction with the various planets, Jupiter, etc., then they could get caught. And there have been proposed that some of the moons orbiting around Jupiter are captured. There's like one that is going the wrong way around Jupiter. And it's been proposed that it is actually a captured interstellar object. We won't know until somebody goes and actually examines these things up close. Because think about what it would take to figure out that an object is interstellar in origin. You would need to be able to sample it, like get a sample back like Hayabusa or OSIRIS-REx, and you would have to be able to test what it's made out of. And then that would, get that chemical fingerprint. Because every object that we've been able to detect, every meteorite that's been found here on Earth, they all have the same exact age. They all formed with the beginning of the solar system 4.5 billion years ago. And so you would find an object and you would know, oh, this one is 8 billion years old. That's weird. So that's what we need, is to find some of those examples. But I mean, I don't know. I know that there have been like grains of dust that have been measured, which are older than the solar system and so have been assumed to come from outside of the solar system. But I don't know of any meteorites, anything significant that's been found. Whoa, what happened there? Okay. Jack D420, are you watching the Starship test flight tomorrow? I'm just using this as an example to talk about the Starship test flight tomorrow. So probably, I don't know. I tend to, with these kinds of things, I tend to tune in at the last minute just to see if it's going to fly, because I've been burned too many times waiting for a rocket to do its thing. So I'll like leave a window on my computer and then, and then watch, work and then just keep an eye on the rocket and see what's happening. And then if it actually does launch, then I'll tune in and grab the computer and run upstairs and tell Carla, and we'll sit on the couch and watch it on the big screen at the last minute. So tomorrow, in theory, around I think 4 a.m. Pacific time is when their window opens. They're going to try to launch the new Starship SN8. And this is the one, and I keep saying this every week, with the little flappy wings. So it's going to have the ability to change its orientation while it's in midair. It's going to fly to 12.5 kilometers and then attempt to return safely back on the landing pad using 3 Raptor engines. So it'll be just like the grain tower that we saw fly. Man, how long ago was it? Like months ago. I don't know. In the year 12,000, we watched it 17 years ago. Anyway, time has no meaning now. But yeah, so we should be able to see this thing lift off, fly to this altitude, return to the landing pad, hopefully test out some of the capabilities, its aerodynamic capabilities. And then if that works, then I think orbital is next. There might be one more test. So what I think is actually going to happen tomorrow, I don't think it's going to get off the ground tomorrow. I think there's going to be a bunch of tests. They're going to have some aborts. They're going to figure out some issues, and then they're going to have to fix it. They've never launched with 3 Raptors at the same time. I'm kind of surprised that they aren't going to do just another 150-meter hop with the 3 engines, because it's full bore. Fire those engines, have them work together. So to do the full 12-kilometer hop is pretty brave. And so I think there's like an even chance that the thing will just detonate on the launch pad. But I mean, starships explode. That's what they do. So I wouldn't be super surprised if we see a starship explode. And then SN9 is ready in the wings. SN10 ready to go. SN11, send me in. So yeah. So we'll see what happens. But no, 4 in the morning, I'm going to be asleep. So, but there's no way. Come on. There's going to be delays. There's going to be aborts. There's going to be changes. We have a rule in the space journalism business that one does not purchase a return flight from a rocket launch. When you go to see a rocket launch, you have to be prepared that this is your home now. You are going to become a Cape Canaveral native or a Boca Chica native. This is your new life now. I have, let's see, OSIRIS-REx launched on time, so I was lucky with that one. I went to go see the space shuttle, and that one got a month delay, and so I missed the watching a space shuttle launch. All right. Curious Borg, will you be able to resolve Jupiter and Saturn at the same time in the same view during the conjunction millions of miles apart? That's cool. Yeah, that's the plan. One on the same screen, we will try to show you Saturn and Jupiter at the same time. In fact, their moons, I've just learned this, that their moons are already starting to mingle because the two planets are getting closer and closer. And obviously, they're super far apart, but from our perspective, they're going to get closer and closer and then just be in the same view at the same time. That's a time saver. We won't have to look at Jupiter and then we get tired of Jupiter and go look at Saturn. We'll just be able to look at Saturn and Jupiter at the same time. The thing that's going to make this may make this tricky is that the brightness of Jupiter and Saturn are vastly different. And so it actually might be difficult to get them looking the same because you have to change the exposure setting on the telescope, on the camera. And so I wouldn't be surprised because oftentimes, when we want to show the moons of the planets, we have to crank up the exposure and then the planet gets totally washed out and then you can see the moons. And then you turn down the exposure and then the moons disappear because they're fainter, but then you can see all the bands across the planet. So I don't know if Jupiter and Saturn seen in the view at the same time will look good. We're going to have to find out. Someone could tell me. I'm sure one of my astronomer buddies will go, yeah, it's not going to work. But somebody I remember was able to show Jupiter and the moons at the same time. But if you've watched any of our star parties, you know that this is always a trick that we have to do, going back and forth between brightness to see the planet and then brightness to be able to see the moons. Andrew Planet, is there a chance that extracting samples from the surface of asteroids to bring back to Earth might not be representative of what's deep inside them, that they've been contaminated by small impacts? Yeah, that is absolutely a significant possibility. And the Hayabusa, the engineers behind Hayabusa, they thought of this. The thing that's kind of amazing about Hayabusa, right, is it took all kinds of rovers and landers to Ryugu, and then sort of as its grand finale, it shot a tank shell at Ryugu, blasted away a crater, and then came down and grabbed its sample from inside the crater, and then that's the sample that it's bringing back to Earth. And so they're actually solving this exact problem, which is that you don't know. You got the outside of the asteroid is probably going to be littered with dust and solar system debris and all kinds of crud. But if you scrape away that top layer, then you're going to get that fresh internal Ryugu goodness, and that's part of what it brought back home. Horizon Brave. If China builds its own space station and let's say the ISS is deorbited later, do you think that they'll then deny us access in the future as a big screw you? Well, you have to define us because, I'm Canadian and I'll bet you that thing needs some arms. Give us a call, China. Yeah, I'm not sure how the politics are going to play out with the Chinese space station. I think that they have put a call to various countries, to join them on their version of the International Space Station, the Chinese, Tianhe. But there are like rules in place for why the US can't participate and vice versa. So I think you're going to need some kind of melting of hostilities between China and the USA before they can be part of that. Other countries, who knows? I think Europe is going to be contributing some parts to the space station, and some other nations are as well. So, NASA could build a space station. I mean, they're going to have the Deep Space Gateway, and they can send people there. They've also, with the return of the Crew Dragon, they've got a lot of capability to like perform a lot of really interesting experiments on Crew Dragon. Like, did you know that the internal space on Crew Dragon is bigger than the Apollo capsule? And so 4 astronauts can be inside a Crew Dragon with more space than the 3 astronauts were inside the Apollo capsule. So there's actually a lot of space. And so I can imagine, instead of having a space station, I can imagine NASA performing some of the experiments, just flying Crew Dragons and performing experiments inside that. So we'll see what happens. I don't really know. I mean, there will definitely have to be negotiations. I mean, we saw with the upcoming Artemis Accord that, you've got signatories from everyone but China and Russia. And so everybody's agreeing on how they're going to work on the moon, except for those 2 countries. So it would be, it would be really good for people to sort this out. And I feel like that was one of the great peacemaking sort of signs of leadership back with the International Space Station was, originally Reagan had proposed space station freedom, and they ran out of funds to be able to launch Freedom. And so they got all of the international partners on board, including the Russians, who were, not super friendly with the Americans at the time. And then the Europeans and the Japanese, and of course, let's get an arm on that thing. And I think that's wonderful. And so I would love to see future collaboration and cooperation. And I think sometimes that is the, sort of like the best way to approach it. So I hope that China will open the doors and let other people come on board and participate in it. I hope that the United States has a better space station for as long as humanly possible. We should be living in space. We should have people in space, on space stations, on the moon, on Mars, all the time. Let's make it happen. All right. So I see your... So JJ asks, hey Fraser, after the second launch failure of the Arianespace Vega, do you think that NASA should reconsider hiring them for the James Webb telescope launch? Maybe NASA should commission SpaceX. That's a tough question. No, they shouldn't recommission. They shouldn't shift away the James Webb Space Telescope to... So, all right, let me tackle this question. I just got to remember, like, do I jump in and answer the question, or do I like try to set some background here first? So James Webb is going to be launching on an Ariane 5 rocket. And so as part of the development of the James Webb is actually an international collaboration. It's not just an American telescope. It's actually got a collaboration of many different countries, including Canada. Canada's providing an instrument for the satellite. And then the Europeans are providing an instrument as well as the launch. And so the launch was decided. Of course, James Webb is late, and so back in the olden days, it was designed to launch on like the safest, most capable rocket around. This was the Ariane 5, and now Ariane has shifted into the Ariane 6 era. There's also the Vega, which has failed twice. And so they're sort of keeping this old Ariane 5 around to just launch James Webb. But, I mean, everything is planned. The rocket is ready. The satellite, James Webb, is pretty much ready. Almost ready. It's going to go on a barge soon. It's going to make its way down on October 21st, 2021. October 31st, no later, James Webb is going to fly. So it would be bonkers to delay the launch at this point. And it's a different rocket. The Vega is not the Ariane 5. Now, obviously, the same people are working on it, but I think it's a hardware issue, not a people issue, not a software issue. Or maybe it was a software issue. I forget exactly why the Vega failed. But no, it would be madness. That thing will never launch. If it doesn't launch on everything's been planned to launch on this rocket, it will launch on this rocket or explode, one or the other. All right. Sorry, there's some very funny questions. Gaurav Sharma, is it even possible to drill through kilometers of rock-hard ice on Europa and Enceladus to confirm subsurface oceans? We barely dig deep here enough on Earth. Yeah, so that is... See, I jump into the question. I got to give some background first. Europa and Enceladus thought to have subsurface oceans. In the case of Europa, it's probably about 10 kilometers below the ice. And then, of course, it's liquid water, probably kind of saline water. It's probably got, geothermal vents at the bottom that are releasing energy and minerals into the water. It's like the best place for life that we know of in the solar system, apart from Earth. So how do you get down to that water from the surface? And we did a whole video on this, but the gist is that you take a nuclear powered, or have an RTG sub probe that lands on Europa and then goes tip down and then just starts to melt the ice in front of it. And then it's reeling behind it a wire. And it just sinks down with gravity through the ice. And then the ice freezes up behind us as it goes and locks that cable into the ice as a way to communicate back with the surface. And it just keeps going all the way down until it reaches the water. And then it sort of, just as it's reaching the water, it stops, opens up the front, little swimmy bots come out and explore the area around, come back to the probe and transmit the data back up to the surface. And what's kind of neat about this is that every part of this has actually been tested out. There are these temperature probes in Greenland that are used today. And they put them on top of the ice and they aim them down, and then they just start to melt their way down through the ice in Greenland. And at very fast, like in terms of meters an hour, it's very fast. And so I think we did the math that you would need a couple of years. It all depends on the width of the probe. So if the probe is very wide, then it will go slower as it's sort of essentially pushing the water, it's melting the water, and the water is trickling around the back. But if the probe is very long and skinny, then it can go a lot faster. And so that's the...
Sorry, something went wrong.
Oh, really?
Please try opening the app to continue.
Sure, Google. No problem. Why are you talking to me? Okay. Oh, Google. There. Anyway, yeah, so thinner probe goes faster, but you have less of a science package. Wider probe can carry more science, but it takes longer to get down there. But every part of this is definitely feasible. It's just a matter of someone willing to spend the money to overcome all of the uncertainties in the process. Arjun asks, could we tell with sonar if we're at a good location to find the water on Europa before we dig? So the Europa Clipper mission, which is going to be launching soon-ish and arriving at Europa later-ish, is going to be equipped with a ground-penetrating radar system on board. And it's capable of, in theory, mapping the ice down to the level of the oceans. So in theory, Europa Clipper will have the ability to determine the depth of the ice and also be able to find any pockets of water. And so one super exciting possibility, because we know that there are plumes of material spraying out of the surface of Europa. And so one idea is that you could send the Europa Clipper, it scans the ice across the entire world and sees the network of channels of water that's somehow making its way up from the ocean down below to the surface and then spraying material out into space. And so, in fact, you may not have to go 10 kilometers, 100 kilometers, however deep the material, how deep the oceans are. You could find one of these pockets and drill into them much more easily. So the most sort of energy intensive and heaviest scientific instrument on board Europa Clipper by far is this ground penetrating radar, but people feel like it's the best part. So that's like the really exciting instrument that's going to be on board Europa Clipper. Tom Zucki says, I think the hardest thing for Europa would be getting a 10-kilometer spool of wire there. That's actually not a problem either. There are these wire-guided missiles that have been used by the military for a very long time. When you see some of these, now I think some of them are like more radar controlled or wireless or whatever, but for the longest time these missiles would have a big spool of wire that would come out behind them, and the missile would launch, and then someone would be on a joystick targeting the missile to the target, and they would go very far. So again, having a 10-kilometer spool of wire, 100-kilometer spool of wire that's very thin on the back is, again, not an unsolvable technical problem. Disasterina, are there oppositely charged magnetars, like a positive one and a negative one? Also, how big a fridge door do you need to stick one on it? So no, you're not going to get a positively charged and a negatively charged magnetar. You're going to get a magnetar it's going to be like a bar magnet. It's going to be like the Earth's. You're going to have a north pole and a magnetic south pole, and then you're going to have really powerful magnetic field lines that are connecting everything up. Every magnetic object that we know of in the universe has a north and a south magnetic pole. In fact, one of the mysteries of the universe is why we don't have these things called magnetic monopoles, which are essentially magnets with only one pole. And so it was predicted that the Big Bang should have generated these monopoles, but they didn't. And so one of the explanations to solve this problem is actually inflation. So no, you're going to have a magnetar, magnetic field like the sun, like the Earth, like a bar magnet, going from one pole to the other. But as things twisting around, it's interacting with its environment, and there's, it's a mess. How big of a fridge? Well, a magnetar can dismantle your atoms at an atomic level. They can just dismantle the bonds magnetically. So I don't think there is a fridge big enough that you could take a magnetar and put it onto, because as you brought the magnetar close to your giant fridge, it would be dissolving the fridge no matter what the fridge was made out of, except for maybe black hole. So if you had a fridge made of a black hole, then you could attach the magnetar to the fridge, but then the fridge would just consume the magnetar. There's no fridge. It's just not possible. IVX isn't the biggest problem that we don't want to bring Earth life to those moons. Yeah, the problem with taking any spacecraft to any of these worlds that are thought to have very habitable environments inside of them, the saline pools subsurface on Mars, the interior of Enceladus, the interior of Europa, any of these places, if you're going to have liquid water, you've got the potential for life, and it's going to be a problem. And so the solution is you've got to have a very, very pristine, cleansed spacecraft. And then I think the challenge that we're finding, you can clean these spacecraft within an inch of your life, and they're still going to have some remnants of Earth life, like cyanobacteria. And cyanobacteria can live everywhere, no problem. So I think that that this is an unsolved problem. Now, there is one little bonus, which is that if you leave your probe on the surface of Europa for a while, it'll get blasted by the radiation from Jupiter, and it's like 1,800 times more radiation load than what you would get in orbit around the Earth. And so it will, in theory, scour your probe of life and then wait a while, and then so clean your spacecraft on Earth in the most clean environment that you can. Then have it travel through space, exposed to the vacuum of space. Then have it land on Europa and sit on the surface of Europa, just kind of basking in the Europan magnetosphere for a while. And then when you're finally ready, then go down. A.B. Scott and Flower asked this question. I don't know the answer. So what is the protocol for an astronaut dying of natural causes while on ISS? What about someone becoming seriously ill or injured? The International Space Station always has the capability to bring people back home to Earth. So there are now one Crew Dragon spacecraft attached to the space station, a Soyuz capsule. And so there will always be, this is sort of one of the requirements, is that no matter how many people are on board, you always need to have enough seats for astronauts to get back to Earth. And so if one of the astronauts was, took ill, had appendicitis, something fairly serious, they would send them back home to Earth on a Soyuz. Now, I don't know whether, or on the Crew Dragon. I don't know whether they would come back alone, they would come back with a crewmate, whether they have to come back with the full complement. It's a good question. But yeah, I mean, if there's any serious risk to an astronaut's health, they come back to Earth. All right. Corey Kearney is saying, so a guy in Israel with real credentials says aliens are real. Thoughts? Okay, Corey, I want to just dismantle the sentence that you just gave me here. So a guy in Israel with real credentials says aliens are real. So a guy, who's the guy? What are his credentials? What does he mean by aliens are real? I'm going to need more information. But I think I can assume that the answer is they're not real. He doesn't have evidence. But I await the evidence. Sounds great. Let's see the aliens. Bring them on. But I'm going to assume that there is no evidence. So, yeah. But if you have it, throw a link or send me an email and I'll take a look at it. But it's never been aliens so far. So I think we can just safely assume it's not aliens, that it's not evidence of aliens. Ever. Till it is. Then it'll be aliens. Joe Kozak, does the Crew Dragon have a heat shield? Seems like a waste. The Cargo Dragon, sorry. Yeah, the Cargo Dragons are reused, aren't they? Now I'm not sure. Someone's gonna have to post in the comments, but I think the Cargo Dragons are reused. So yeah, they do have a heat shield, just like Crew Dragon. I don't know if they do reuse them, but they are reusable. 011 Deco Rivanto. The proposed Europa lander will only examine surface sample from 3 centimeters deep. Do you think that's enough? So I'm not sure the state of whether or not there's going to be a lander on the Europa Clipper. This is, originally the scientists didn't ask for one. They wanted to send the orbiter, analyze Europa, and then send then when they know, they understand the ground truth, then they'll send a lander to a very specific location and fulfill some certain objective. So to just bolt on a lander that can handle whatever mysteries Europa throws at them is a bit of a long shot. But that's, that's the way the Japanese with the Hayabusas go, and I love that. So I guess I love it. Is 3 centimeters enough? Well, it's a start. Like, let's start there. You're going to have this really cool ground penetrating radar. You're going to be able to send the lander to the best spot on Europa, and then you're going to be able to drill down and 3 centimeters and sample something. So it's better than nothing. Let's just start there. Why like, we have no samples. Nobody has ever put a lander on any of the icy moons in the solar system. Let's do that. Let's start there. Oh, there you go. Jerusalem Post. Former Israeli space security chief says aliens exist. Humanity not ready. I'm ready. I am ready. I can handle. Tell you what. Tell me, and then I'll decide if the rest of humanity is ready. But I'm ready. I can handle it. And I'll tell you. All right. There you go. There's the dude. Okay. Romulus XC. Why does Starship not have escape pods? They couldn't make it work on the design of Starship. So, when you have escape pods on a spaceship, that's equivalent of you having tiny little spaceships. And each one's got to have its own atmospheric system. It's got to have its own rocket system, its own escape system, its own landing system. It's a lot of systems. Like, when you think about how Crew Dragon works, you've got the expendable rocket down below, and then Crew Dragon has its own rocket system as well. And so if there's any problem with its booster, it can detach from the booster and then land safely, and the astronauts can walk away alive. But with Starship, both parts are reusable. And so if there's a problem with the first stage booster, then Starship can detach, and then it didn't get enough velocity, and so it can return safely to Earth. But if there's a problem with Starship, there's nowhere else to go. So I think they're hoping that it'll just be reliable. Joe Kozak is asking about the Gateway Foundation. I don't know. Is there something interesting that's happened about the Gateway Foundation? Please let me know. Arjone, is it a possibility to have a moons mission for the Jovian moons, like a mission to study all the moons of a gas giant? Would it be too expensive? Not only would it not be too expensive, it's happening. It's the JUICE mission. The European Space Agency is sending a mission to all of the Jovian moons, except for Io, around the same time that the Europa Clipper is. It's going to be going to Ganymede and Callisto and Europa, but mostly Ganymede. And so you're going to get a much better investigation to the rest of the Jovian moons. Personally, I'm super excited about Ganymede. Like, I know everyone's crazy for Europa, but don't forget about Ganymede. Ganymede has a subsurface ocean just like Europa. But it also has a magnetosphere. But you didn't know that. Ganymede is the only other place in the entire solar system, the only moon with an internal magnetosphere like the Earth, and a subsurface ocean. So Ganymede, and that's a big reason why JUICE is going to be going and really in the end orbiting around Ganymede and exploring that moon. It's farther away from Jupiter, so it doesn't have to get caught in the magnetosphere of Jupiter. So it's a great place to explore. So yeah, absolutely, that's the place to go. Ganymede. Ganymede is the new Europa. All right. So I think we're going to wrap things up. I just want to remind everybody, if you enjoy space news, of course, I'm the publisher of Universe Today, and you should come and check out our amazing website. I've just been so impressed by the amount of just incredible reporting that's happening. Alan Boyle is covering all of the stuff that's happening with Hayabusa and Chang'e. We've got Matt is covering everything on Starship. Nancy Atkinson is covering tons of stories. Evan Goff. We've got some new reporters coming on board. It's a really good time. We've got both Paul Sutter and Brian Koberlein, two PhD astrophysicists, breaking down black holes and cosmology for you. So come and check out Universe Today. And if you want it in a nice, convenient form, subscribe to the newsletter, universetoday.com/newsletter. We've got If you missed it, I did an interview like just a couple of weeks ago with the project manager for the JUICE mission, so you can check that out. We got the weekly space hangout this week, new astronomy cast on Friday. We've got my interview with Elizabeth Howell, Canadarm in collaboration, Elizabeth and I will be speaking in our native Canadian accents for the episode. And then, of course, we're going to try another Star Party on Saturday night. So lots of great content coming your way. I hope you enjoy all of it and more interesting interviews. And as always, if there's some expert, researcher, anything you want me to dig into, bring as a guest here on the show, just please let me know. My email's in the show notes. Just reach out. I'm here for you. All right. Thank you, everybody. Thanks to all of the moderators. Special thanks to Nancy for copy-pasting questions. Nancy, we got a solution for you. It's almost ready to go. Make your life a little easier. So we will see all of you whenever. I mean, I'm on the internet all the time, so we'll see you soon. Thanks, everybody. I don't know how to stop this.